This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Hello everyone, and welcome to our discussion. Today we're diving into the world of open educational resources, OER, and how they're revolutionizing physics education, specifically focusing on two technical papers detailing the use of interaction simulations. We'll be examining how these resources leverage technology to enhance student learning and understanding of key physics concepts. Let's start with the first paper. What immediately strikes you about the HTTP headers presented?
The HTTP headers in the first paper reveal a standard web server response, HTTP/1.1200 OK, indicating a successful request. Several headers are noteworthy. Content encoding. Zip shows the content is compressed for faster transmission. Access control allow origin, suggests the resource is accessible from any origin, promoting broad usability. And the presence of upgrade, H2/H2C, indicates support for faster HTTP/2 protocol. The last modified date shows when the resource was last updated. These headers are all standard and efficient for web delivery.
So it's a pretty standard, efficient setup for delivering web content. What about the second paper? Are the headers similar, or are there any significant differences?
The second paper's headers also show a successful request, HTTP/1.1200 OK, but with some key differences. Transfer encoding, chunked, indicates the content is sent in chunks, useful for dynamically generated content. The expires header, set far in the past, and the cache control and pragma headers all enforce a no-cache policy, ensuring users always get the latest version. The set cookie headers suggest session management, possibly for user authentication or tracking. The X content encoded by Joomla header reveals the content management system used. These headers suggest a more dynamic and potentially security-conscious environment.
That's interesting. The difference in caching strategies is particularly notable. The first paper seems designed for efficient delivery of static content, while the second prioritizes delivering the most up-to-date information, perhaps for a frequently updated website. Looking at the content of the second paper, what's the main focus of this OER website?
The website focuses on providing a wide range of interactive physics resources categorized by topic and educational level, secondary and junior college. It features simulations, videos, and supporting materials, all designed to enhance the learning experience. The tracker bouncing ball model is highlighted as a prime example of their approach.
And what exactly is this tracker bouncing ball model? How does it work, and what concepts does it teach?
The model uses Tracker, a free video analysis software, to allow students to analyze the motion of a bouncing ball. By tracking the ball's movement in a video, students can extract data on position, velocity, and acceleration, and then use this data to explore concepts like kinematics, dynamics, energy conservation, and the coefficient of restitution. It's a hands-on approach to learning fundamental physics principles.
So it's not just a passive video, it's an interactive tool that lets students actively engage with the data and the physics concepts. The provided text includes a study guide with short answer and essay questions. What are some of the key learning objections highlighted in this study guide?
The study guide aims to help students understand key concepts with kinematics, dynamics, energy conservation, and the coefficient of restitution through the analysis of the bouncing ball. It encourages students to analyze data, identify sources of error, and apply their understanding to solve problems. The essay questions push them to think critically about the strengths and limitations of using simulations and real-world experiments.
The study guide seems well-structured to promote deeper understanding. The FAQ section also provides helpful information for users. What are some of the key advantages of using this type of OER in a classroom setting?
The key advantages are accessibility, free and open, interactivity, engaging students actively, and adaptability, suitable for different learning styles and levels. The OER also promotes self-paced learning and allows teachers to easily integrate the resources into their curriculum. The multi-platform compatibility further enhances accessibility.
The emphasis on accessibility and interactivity is crucial for modern education. The papers also mention various other simulations available on the website. What are some of the other topics covered by these simulations?
The website covers a broad range of physics topics, including wave phenomena, electricity and magnetism, modern physics, and even some chemistry and mathematics. The variety of simulations caters to a wide range of interests and learning objectives.
The breadth of topics is impressive. It seems like a valuable resource for both teachers and students. What are some potential limitations or challenges associated with using such OER in education?
While OER offers many benefits, challenges include ensuring the quality and accuracy of the resources, providing adequate teacher training and support for effective integration, and addressing potential technical issues or compatibility problems. Regular updates and community feedback are crucial for maintaining the quality and relevance of the resources.
And that's a very important point. Maintaining quality and relevance is essential for any educational resource. The second paper mentions a login system. What is the purpose of this login system on the website?
The login system likely provides access to additional features or resources, perhaps for registered users or teachers. It could also be used for tracking usage statistics or facilitating communication within a learning community. The specific functionality isn't explicitly detailed in the provided text.
That makes sense. It could be used to create a more personalized learning experience or to track student progress. The website also mentions contributions. How can users contribute to this OER project?
Users can contribute by developing and sharing their own interactive models, translating existing models into different languages, and providing feedback and suggestions for improvement. This collaborative approach ensures the continuous growth and improvement of the OER resources.
That collaborative aspect is a significant strength of OER. It fosters a sense of community and allows for continuous improvement based on user feedback. The papers highlight the use of Tracker software. What are some of the advantages of using Tracker for video analysis in physics education?
Tracker offers a user-friendly interface for analyzing videos, allowing students to easily track the motion of objects and extract quantitative data. This hands-on approach helps students connect theoretical concepts with real-world observations, fostering a deeper understanding of physics principles. Its open-source nature and multi-platform compatibility further enhance its accessibility.
The combination of interactive simulations and video analysis tools like Tracker seems to offer a powerful approach to physics education. What are your overall thoughts on the potential impact of these OER on student learning and engagement?
I believe these OER have the potential to significantly enhance student learning and engagement in physics. The interactive nature of the simulations and the hands-on approach of video analysis can make learning more engaging and effective, particularly for students who benefit from visual and kinesthetic learning styles. The accessibility of these resources can also help bridge the gap in educational opportunities for students from diverse backgrounds. The collaborative nature of OER really strengthens its potential impact. Thank you for this discussion.